Hi, my name is Kevin O'Connor.
And I'm Kara Clark.
And today we are going to take you through the steps of the California Rapid Assessment Method for depressional wetlands.
We're here in Fremont, California, in the San Francisco Bay Area. We're going to be assessing Tyson's Lagoon. This wetland is a historical sag pond formed by the Hayward Fault. However, it is highly altered from its historical condition.
The surrounding land uses include commercial and urban. And directly behind the pond, there are several stormwater treatment ponds that treat runoff from the adjacent urban environment.
Thanks for joining us. We hope you enjoy the course. Today's assessment area, Tyson's Lagoon, is a perennial wetland. It has water year-round, both from groundwater springs and stormwater inputs from the surrounding urban area. However, we also have an example of a seasonal wetland. This area behind us receives water from Tyson's Lagoon during high stage events in the winter months. And in the summer, it dries out, and the plants here are adapted for both seasonal inundation and seasonal drying. There is a mix of wetland and upland plants. This Spergularia is adapted to seasonal drying. It's an annual plant which grows up in the spring and summer when the wetland is dry. And it sets its seed bank, which stays here at the wetland throughout the winter. There's also a grass here, rabbit's foot grass, which is another wetland plant. So these are both wetland indicators at this site that show that this seasonal dry area is also a wetland. The first step to conducting a CRAM assessment is to define your assessment area, or AA. The assessment area must be less than 2 hectares, and it must encompass only one wetland type. Here at Tyson's Lagoon, the wetland is larger than 2 hectares. Therefore, we had to divide it into more than one AA. We decided to focus our assessment today on the western half of the wetland.
Here I am at the north end of Tyson's Lagoon, looking to establish the edge of my assessment area. Table 1 in your field book lists features which should be used to establish this edge, while Table 2 lists features which should not. Here's an example of a transition in wetland type from riverine channel into depressional wetland. At the edge of the tules is where I would put the edge of my assessment area here.
When setting up your assessment area, you need to make a decision about how wide to make the AA. This is based on the transition from wetland to upland, the presence of a foreshore along the edge of the wetland. You also include any overhanging branches which provide input to the wetland. You include the entire footprint of any trees or shrubs which are overhanging the wetland. These plants can provide allochthonous input. They provide leaf material which adds to nutrients and energy in the wetland system. So these influences on the wetland need to be included in your assessment area.
To assess aquatic area abundance, use your aerial image. Make sure your AA is drawn on your aerial image. Draw lines that are 500 meters long in the cardinal directions, emanating out of a centroid. For each of those lines, determine the percentage that crosses over aquatic features of any type. Average those 4 percentages and refer to the appropriate rating table for your score. Here at Tyson's Lagoon, we are in an urban environment. As a result, there was very little surrounding wetland habitat, and we got a score of D for this metric.
To assess the percent with buffer, you look along the perimeter of the assessment area to see where buffer is present, at least 5 meters wide. In this particular area, there's less than 5 meters of buffer between the edge of the AA and the fence and road adjacent to us. Therefore, in this area, there is no buffer present. You measure the perimeter of the assessment area and look to see what proportion of the perimeter has buffer present. The buffer width is measured on aerial imagery, drawing 8 lines away from the assessment area to where the buffer is broken. At this site, the buffer is broken by the fence and parking lot behind us. The parking lot is associated with the commuter train. This is a major development which breaks the buffer. The fence itself also breaks the buffer because it is a barrier to wildlife movement. Large mammals could not make it through that fence to enter the wetland. When drawing your buffer lines, distribute the 8 lines radiating away from your assessment area, evenly distributed across the perimeter of the assessment area to where the buffer is broken. The buffer condition is assessed in the area where buffer is present. We don't look at the area outside of the buffer where buffer is broken, such as the parking lot above us. The buffer condition metric looks at the amount of native and non-native vegetation, the presence of soil disturbance, and the potential for human visitation. Here at this site, we have a mix of natives and non-natives. We have the non-native Rumex crispus, as well as some native forbs and native trees. There's a little bit of soil disturbance behind us on the hillside, but for the most part, it's fairly undisturbed. There's not a lot of human visitation here. This site is closed to the public. There are school groups that come through, but it is relatively undisturbed. So I would give this site a buffer condition score of a B. The water source metric assesses the water sources that affect the dry season condition of the assessment area. In practice, this metric involves aerial photo interpretation, which allows you to estimate the amount of urban or agricultural area that is draining to your assessment area. Here at Tyson's Lagoon, the main water sources are groundwater springs, as well as drainage from the surrounding urban area. The urban area covers much more than 20% of the surrounding landscape. Therefore, based on the narrative table, we would assign a score of a C to this assessment area.
Metric 2 of the hydrology attribute is hydroperiod. This metric looks at the frequency of inundation in your wetland over the course of a typical year. To assess this metric, look around the perimeter of your wetland for any indications of water being actively moved into or out of the wetland. Here at Tyson's Lagoon, there are many examples of stormwater outfalls flowing directly into our assessment area. This, in effect, increases the inundation at this wetland. As a result, we give this wetland a score of B.
The hydrologic connectivity metric looks at the transition zone between the wetland and the upland. A transition zone can provide a gradient for moisture niches, which provide habitat for different plant and animal species. We look for a broad, even transition where as water rises, it allows the footprint of the wetland to expand quite a lot. Here at this area of Tyson's Lagoon, the bank is very steep, so we really have very little transition zone between wetland and upland. To assess this metric, you look at the perimeter of the entire wetland that you're assessing and estimate the proportion of the boundary which either has a transition zone or does not have a transition zone, as we see here. So this portion of the wetland would be measured as lacking that transition zone. Hydrologic connectivity describes the ability of water to flow into and out of the wetland. Here in this area of Tyson's Lagoon, we have a nice broad transition zone, which allows rising waters to come up out of the main wetland and onto this floodplain. This creates a broad transition zone with moisture niches, which creates more complex habitat. At this site, more than half of the perimeter of the wetland has a good transition zone. Therefore, we assign this site a score of a B for this metric. The structural patch richness metric is a tally of the number of physical patch types present in the assessment area. This metric is different from the topographic complexity metric in that it assesses the number of patch types, whereas topographic complexity assesses the interspersion and overall variation of patch types in the assessment area.
Rack is an accumulation of natural or unnatural floating debris along the edge of a wetland. It can serve as a major source of detritus and enhance the physical structure of the edge of your wetland.
Many vertebrates make burrows for their dens or foraging. This is an example of an animal burrow. The soil is disturbed, which redistributes the nutrients and also aerates the soil. To include this patch type in your assessment area, you must have evidence that a population of burrowing animals is occupying the assessment area. A single burrow is not enough to count for this patch type.
Filamentous macroalgae, occurring here on this senescent typha, can occur on benthic substrates as well as the water surface. In ponds, this can serve as a major source of primary production as well as food and habitat for fishes and macroinvertebrates.
Here we have a great example of a non-vegetated flat. A non-vegetated flat is an area of clay, silt, or sand. It can be a mix of substrates. It's an area that provides good habitat for shorebirds, wading birds, and as it extends into the water, it can also provide resting habitat for fishes and other aquatic animals.
Areas of open water in depressional systems provide important foraging habitat for waterfowl and other bird species.
Here at Tyson's Lagoon, we have a great example of a standing snag. A snag is any dead tree that is still standing upright, is at least 3 meters tall, and at least 10 centimeters in diameter. Snags provide great habitat, perching habitat for songbirds and raptors, and also potential nesting habitat for small mammals or birds such as woodpeckers. In this case, the birds can use the snag to overlook the wetland and interact with the wetland from that perch.
Swales are broad vegetated features that convey flood flows into and out of wetlands. Here at Tyson's Lagoon, we have an example of a very broad swale with steep berms at each edge and tules across the center. Floodwaters come up out of the pond across this swale feature and into adjacent seasonal depressional wetlands. As seen in plan view, a variegated shoreline resembles a meandering pathway along the edge of the wetland. As opposed to a straight shoreline, a variegated shoreline provides enhanced contact between the land and the water.
Here at Tyson's Lagoon, we have a total of 8 physical patch types. This gives us a B for this metric.
When assessing topographic complexity in depressional wetlands, you want to look along the perimeter of your pond for macro topographic features such as benches, and micro topographic features such as soil cracks, fallen logs, or boulders. Benches can be indicated by changes in vegetation along the edge of your pond. Here we have a change from cattails to curly dock and smartweed, showing this single bench along the edge of our pond. That, combined with the lack of microtopographic features, we give this a score of B.
The plant community metric is composed of 3 submetrics: the number of plant layers, the number of codominant species, and the percent invasion. For this metric, we look at vascular plants that are present in the assessment area. So we don't include mosses or lichens or that sort of thing. We include herbs, forbs, shrubs, and trees that are present in the assessment area. To assess plant community, you fill out the worksheet that is included in the data sheet with the species present at the site, and then you use that worksheet to assign scores for each of the submetrics. To assess the plant community, we first look at the number of plant layers. Here we have a very tall layer. An example is this willow tree, which is greater than 3 meters tall. We also have behind me a tall layer, this California bulrush, which is between 1.5 and 3 meters. Down here, we have an example of a medium layer. This goldenrod is between 0.5 meter and 1.5 meters. And we also have a short layer, this burr clover, which is less than 0.5 meter tall. The number of codominant species are recorded on the plant community data sheet. A codominant species is one that is at least 10% of the layer that it is found in. For example, at this site we have both tules and cattails. Both of these are in the tall layer, 1.5 to 3 meters tall, and each of them comprise at least 10% of that layer. Therefore, they are both codominant species. At this site, we have a short layer with burr clover. We have a medium layer with smartweed and Himalayan blackberry. We have a tall layer with cattails, tules, as well as a shrub. And then we have a very tall layer with red willow, arroyo willow, and the ash tree. This makes a total of 9 codominant species, which is an A for this submetric. The third submetric in the plant community metric looks at the percent invasion. To assess this metric, you calculate the proportion of codominant species which are invasive. Here at this site, we have Himalayan blackberry, an invasive species. We also had burr clover, which is another invasive species. So we had 2 invasive species out of 9 total, which gives us a B for this submetric. The invasive species status is based on the list generated by the California Invasive Plant Council. So you determine whether a species is invasive based on whether it is in their list.
Metric 2 of the biotic attribute is horizontal interspersion. It refers to the variety and mixing of plant zones along elevational gradients, moisture gradients, and other environmental factors. Here at Tyson's Lagoon, we have several plant zones. Here you can see a buckeye and willow zone. Off in the distance, we have 2 different emergent vegetation zones, that being typha and tule. And then in the foreground, a brush zone made up of invasive blackberry.
The vertical biotic structure metric is assessed in one of 2 ways. You can look at the overlap of plant layers or at the entrainment of litter and detritus in the marsh vegetation. The overlap method is used in wetlands like this one here at Tyson's Lagoon, where we have a large area of open water surrounded by a fringing marsh. We look at the overlap of layers. Behind me, we have a good example of moderate overlap, where 2 layers are overlapping each other. We have the willow tree and the bulrush providing moderate overlap. Abundant overlap would be 3 layers overlapping each other. To assess this metric, you look at the proportion of the assessment area, which has either moderate or abundant overlap, and use that number to guide the scoring.
We hope you enjoyed the course.
We'd like to thank the people who allowed us to be here, Joyce Bluford with the Math and Science Nucleus and the County of Alameda.
For more information, please go to our website.